Welcome to Beta Online Learning. This is a video for the 10th standard CBSE mathematics on the topic circles. In this video, we are going to see all you need to know about circles, the basic concepts and theorems. This is the part 1, which covers the basic concepts and theorems related to circles. In this video, we will also present to you the theorems you had already learnt in 9th grade. So this is a 9th grade as well as 10th grade. So on the topic circles. In the next part 2, we will be solving some exercise questions in the NCERT book as well as some additional HOTS questions. Major subtopics in this video: what is a circle, parts of a circle, basic concepts, circle theorems. This includes theorems you all already learned in 9th grade. Now let us go into the video. What is a circle? Basic question. A circle is the locus of all points which maintain a constant distance from a fixed point. By locus, what do we mean by locus? Locus means path traced, or it is a path that is covered by the points, traced by these points. Any collection of points which maintain a constant distance from a fixed point. The constant distance is called the radius of the circle, and the fixed point is called the center of the circle. Here we have the figure. The circle, the center is usually denoted by the letter O, capital letter O, and here the radius, small r, denoted by the letter small r. The OP, P is any point on the circumference of the circle. This part is called the circumference, as we will see later, the parts of the circle. This is just the definition of a circle, where we have defined the center point, the point which maintains the fixed distance between the point and the fixed point. This is a fixed point, actually. The fixed distance is the radius, the constant distance. OP is the same throughout any point on the circumference of the circle. And these are the parts of the circle. Parts of a circle we will see one by one. Center, radius, diameter, circumference, tangent, secant, chord, arc, segment, and sector. Basic concepts. We are going to define some of the basic terms related to circles. Circumference of a circle can be defined as the distance around it. That is, it can be understood with an example. Suppose a wire of length 10 centimeters is bent so that it forms a circle. Here, the circumference is equal to the length of the wire which forms the circle. That is 10 centimeters. Secant. In the figure below here, we show a circle and a straight line, a full line that intersects the circle at two distinct points on the circle itself. See, you have P and Q. AB is the line which intersects the circle whose center is O at two distinct points P and Q. Hence, AB is called the secant of the circle. There is the part of the secant here, the part of this chord, that is the part of the line AB that lies within the circle, is called the chord. The chord passes through, a chord that passes through the center is called the diameter. And it is the largest chord of the circle. Next, we see the tangent. In this figure below, we represent a tangent which touches the circle at one and only one point. Just touches the point, touches the circle at one point P. AB is a line which touches the circle at P, and that point is called the point of contact. This point P is called the point of contact, and O is the center of the circle. Exactly at one point it will touch. Called a line segment joining two different or distinct points on the circumference of a circle is called a chord of the circle. A circle can have any number of chords. Diameter is the largest chord of a circle. Arc. A part of a circumference of the circle is known as arc, as an arc. An arc is a continuous piece of the circle. Here you see the portion PAQ is one part of the arc, one arc. And the other arc is PBQ. This is another arc. So these are parts of the circumference of which the circle forms. The circle is the whole. It's only a part of the circle. The part between P and Q is known as the arc. Segment. Part of a circle bounded by a chord and an arc is known as a segment of the circle. You can see the segment here. The chord PQ divides the circle into two segments. That is, here we have a minor segment, a small part. The minor segment is the smaller segment. The segment is this part PAQ, which is bounded by the chord PQ and the arc PAQ. This is the minor segment, which is the smaller part of the circle. The remaining part, that is a bigger segment, that is the major segment, PBQ, which is the remaining part of the circle, is called the major segment. It is that part of the circle that is bounded by the chord PQ and the remaining part of the circle, that is PBQ, the arc PBQ. This is called the major segment. Sector. Sector of a circle is the part bounded by two radii. The plural for radius is radii. The two radii are OA and OB here, and the arc AB, that part of the circle that is between A and B, that is called arc. So this area, this is called the sector. The part of that circle that is AOB, this part is called a sector. It is bounded by an arc and two radii. Two radii and an arc of the circle. This diagram shows all the parts of the circle. See, arc is given here. We show the various parts of the circle. Sector is shown in green color here. And the segment is shown in blue color here. And the arc is shown in red color here in this figure. And the figure on the right, we have secant diameter, which passes through the center, the radius, and the point of contact of the tangent. This is a tangent here and the point of contact. So these are the different, and chord is also there. So these are different parts of the circle here. These are different parts of the circle, and thereby we have some important theorems. Some important theorems related to circles. Some important theorems related to circles. The perpendicular from the center of a circle to a chord bisects the chord. Of course, we have seen this in 9th itself. You are 10th grade students, but already in 9th grade, you have already learned these theorems. These two theorems. The converse of the above theorem The line drawn through the center of a circle to a chord to bisect the chord is perpendicular to the chord. First, the perpendicular bisects the chord. The converse of this theorem says the line drawn through the center of the circle to the chord to bisect the chord is perpendicular to the radius. This is the converse, and you can see this figure here. In this figure, it represents a chord AB, and OM is a line through the center, passing through the center, and it bisects it. We can say M is a midpoint. In that case, we can say that OM is perpendicular to AB. On the other hand, if his OM is perpendicular to AB, then M is the midpoint of AB. These are the two theorems which you learned in 9th. Another few more theorems learned in 9th, you just have to recall. The angle subtended at the center of a circle is double the angle subtended at the remaining part of the circle. Here, remaining part of the circle. The angle subtended by an arc, ABC, here, you can see this. AOC. The angle AOC is the angle subtended by the arc ABC at the center. And the angle ADC is the angle subtended by the same arc ABC at the remaining part of the circle, ADC. So we can say that it is angle AOC is twice the angle ADC. This is also a theorem in 9th. Angles in the same segment are equal. This figure depicts that theorem. Angles in the same segment means we have the same segment here PQ, here PAQ, angle PAQ and PCQ. PAQ and PCQ are the two angles in the same segment. And angle POQ is the angle subtended by the same arc, PQ at the center. So now you can visualize, recall this theorem. Then we can go to the 5th point. That is, one and only one circle can be drawn passing through three given non-collinear points, which only means that just like a straight line, only one straight line can be drawn through two fixed points. 2 points fix a straight line. Similarly, three non-collinear points. If the 3 points are not in the same straight line, you can draw only one circle passing through all the three given points. The term that is given to these 3 points is concyclic. If 3 or 4 points are said to lie on a circle, those points are said to be concyclic. This is a theorem on cyclic quadrilateral. Cyclic quadrilateral. A quadrilateral which is inscribed inside a circle, or it has a circle circumscribed about a quadrilateral. Both ways we can say that. A cyclic quadrilateral is a quadrilateral which is inscribed within a circle, or a circle is circumscribed about a quadrilateral passing through all the 4 points. See, just A, B, C, D. All the 4 points of the quadrilateral, all the 4 vertices of the quadrilateral lie on the same circle. Then it is a cyclic quadrilateral. The sum of the opposite angles. We know already angle sum property. We know that the sum of all the angles in a quadrilateral, any quadrilateral, is 360 degrees. But this is a special property for cyclic quadrilaterals, where the sum of the angles, the opposite angles of a cyclic quadrilateral is equal to 180 degrees, or 2 right angles. So angle A plus angle C is equal to 180. Angle B plus angle D is also equal to 180 degrees. Now coming to the theorems which you are learning presently in the 10th grade. Tangent drawn to a circle perpendicular to the radius at the point of contact. tangent drawn to a circle is perpendicular to the radius at the point of contact. See, this is the figure. You have the circle, you have the radius, the line passing through the radius at the point of contact, OP. See, this is perpendicular to the tangent at P. There is another theorem also. Tangents drawn from an external point are equal in length. Tangents drawn from an external point to a circle are equal in length. That means from here, we draw two tangents, PQ and PR, to the circle with center O. The two tangents are equal in length. That is, PQ is equal to PR, which can be proved by congruence, RHS congruence rule of the two right angle triangles, because we know that these two are ORP and OQP are right angle triangles, because you know that the tangent is perpendicular to the radius at the point of contact. So that is why these two are right angle triangles. So we have the two right angle triangles, the hypotenuse is common, two radii sides are equal, and hence congruence, and therefore PQ is equal to PR by CPCT. That's all. So it can be proved. Finally, there is one theorem which is not in your textbook, but it is an important theorem which can solve many complex problems in circles. The angle that lies between, this is called the alternate segment theorem. The angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. This is the figure. The center has not been marked as O here, but this is the center. The center is in the middle there. Inside the circle, there's a center. And we have drawn two radii. And first of all, let me describe this circle diagram. This is a tangent at A. The A is the point of contact. AC is one segment, and AB, here the remaining ABC, here AC is a chord actually. The angle made between this tangent and the chord is tangent at A, and the chord AC is marked as theta here. This angle is equal to the angle in the alternate segment, the other segment, not this segment. The segment here is, this is this segment, and the alternate segment is the other segment, ABC, the angle ABC, which is same as theta. It can be proved, of course, if O is the center of the circle, we can join the center. Two radii can be drawn. That is, in the triangle AOC, we will mark it at O here. We have this an isosceles triangle. The two angles OAC and OCA are equal. Angles opposite to equal sides. And therefore, we can say that this angle OAC is 90 degrees minus theta, because we know that OA is perpendicular to this tangent. So this OA makes 90 degrees with this tangent. So the remaining angle will be the OAC, will be 90 degrees minus theta. And similarly, OCA is also 90 degrees minus theta. So using the angle sum property of this triangle OAC, we will say that angle, this the sum of all the three angles, angle AOC plus these two angles, which is angle AOC plus 90 plus theta, 90 minus theta plus 90 minus theta, which is 180 degrees minus 2 theta, is equal to 180 degrees, which means 180 degrees will get cancelled. So 2 theta. So angle AOC becomes 2 theta. That's all. So we can find angle AOC from this, at 2 theta. Now, by one of the theorems which you have learned in 9th standard, that is, the angle subtended by a chord, an arc, or this segment, we see at the center, by this arc at the center, AC at the center, is double the angles subtended at the remaining by the same chord at the remaining part of the circle, that is ABC. So 2 theta means it should be half of that angle ABC, which is equal to theta itself. And thereby we have proved that the alternate segment theorem. And that is the all in this video, because we have covered almost the basic concepts. What all we have seen, just we'll quickly go through the various. We have seen just the parts of the circle. What a circle? What is a circle? All you want to know, all you need to know about a circle, we have covered this here. That's all. Parts of a circle. Then we have gone to the basic concepts of the various definitions called tangent, arc, segment, and so on, sector, and so on, and some important theorems related to circles. These are the concepts we have covered in this video. In the second part to come, we will solve some exercise questions in circles and also some complex odds questions.